Number 12, perform the indicated operations with radicals. So we have the square root of 20 plus 5 times the square root of 45. And so, what are the things we know about radicals? Remember that we can write this square root of 20 as the square root of 4 times 5, because that's what 20 is. And I can write 45 as the square root of 9 times 5. Agreed? That's what 20 is, and that's what 9 is. Or that's what 45 is. Now, this thing is equal to the square root of 4 times the square root of 5. Okay? That's one of the properties of square roots, is that if you have a multiplication sign in there, the square root of a product is the product of the square roots. So I can break them up. And similarly, I can break this one up. I can break this up into the square root of 9 times the square root of 5. Okay? It looks worse right now, but it's going to quickly get better because the square root of 4 is equal to 2. So this is 2 times the square root of 5. And here the square root of 9 is 3. So this is 5 times 3. 5 times 3. 5 times 3 times the square root of 5. So this is equal to 2 times the square root of 5 plus 3 times 5 is 15 times the square root of 5. And you add all those square root of 5s together, and what do you get? 17 times the square root of 5. So hopefully that's an answer. Yes, I see it there. Okay, so that's number 12. That was number 12. '16 says, which of the following are correct? So I'm just going to write them on here. This is square root of a to the 6th times b to the 10th. And let's just, I'm going to just do this problem. Another way of writing this is a to the 6th times b to the 10th, all to the 1/2 power. And when you take the product of things to the 1/2 power, or to any power, you can just take this thing to that power times this thing to that power. And finally, when you have one power raised to another power, you just multiply them. So that's going to be a to the 6/2, which is a cubed. And this is going to be b to the 10/2, which is b to the 5th. So that should be the right answer, and that's what the paper claims, the test claims. So that one is correct. Okay, that one's correct. Let's try the next one. I'll leave that one up there. 36 b to the 36th, the square root of that. So let's see, I can do the same thing here. I can write this as the square root of 36 times the square root of b to the 36th. I can write it like that. And then, notice here I wrote it like this first, and then I broke it up. I can also keep the square roots first and keep the multiplication sign, and then take the square root. So now the square root of 36 is 6. And here I can write this as b to the 36th, all to the 1/2 power. Because when you take the square root of anything, you're taking it to the 1/2 power. So that's going to be 6 times b to the 36 over 2 is 18. So it's going to be 6b to the 18th. That one looks good. Okay. Next one says, can I take square root of 25, multiply it by the square root of 2, is that equal to the square root of 50? And the answer is yes, because again, as long as things are being multiplied, I can take the product of square roots, and that's equal to the square root of the product. So that's correct. That's correct. Okay, I guess I have to erase these now to give me some more room. Number D says, is this the case? A squared plus B squared, is that equal to, basically, is that equal to the square root of A squared plus the square root of B squared, which is just A plus B. Is that correct? We just said that if these two things are multiplied, then you can break it up. What about if they're added? Can you break it up then? Well, let me show you that you can't. Let me show you that you can't. Here's my simplest example. 3 squared plus 4 squared is equal to 9 plus 16. 9 plus 16 is 25, and the square root of 25 is 5. So we know for sure that that's equal to this is equal to this, and this is equal to this. Now, if you really can break this up and just say that this is equal to A plus B, that would mean that this is equal to 3 plus 4, but 3 plus 4 gives you 7. And 7 is not equal to 5, which means that is not the case. It is not the case with a plus sign in there that you can just break it up like that. Okay, so that one is incorrect. Okay, let's look at these other 4, just because when you take the midterm, they're going to be in any order, and you want to be able to look at each one and determine which one is correct and which one is not. So here's the next one. It's 8 over 50 b squared. And before I go any farther with that, I'm going to do some reducing inside. I'm going to write this as a 4 over 25 b squared. I just factored a 2 out of both the 8 and the 50. And now, just like with multiplication, division is the same thing as multiplication. I can break it all up, and I can also break this one up. I can write that as 25 and the square root of b squared. As long as they're being multiplied and divided, I can break them all up. And now the square root of 4 is 2, the square root of 25 is 5, and the square root of b squared is just b. Because what does that mean? That means b squared to the 1/2 power, and you multiply those out, you're going to get b to the first. Okay, let's continue. Had a little technical glitch there. So that was E. F, this is 15. F says the square root of A over B. And here's one thing you can do with that. I can multiply both the top and the bottom by B. That'll make the bottom B squared. And then I can break it up again, since everything is being multiplied and divided. And then since the square root of b squared is just b, that's just going to be that right there. So that one was good. This one here, if you have the square root of a over the square root of b, again, when things are multiplied and divided, you can just combine them like that. And finally, the square root of 1/2. You can multiply both the top and the bottom by a 2. And then break it up. And here I have the square root of, I'll write it as square root of 4. And the square root of 4 is just 2. So there you go. So that's the end of number, that was number 16, rather. That was number 16. Okay, number 17. Number 17 says, which of the following is equal to 7b? Well, let's see. I think you have here b plus b plus b plus b plus b plus b plus b. and you have 7 of those, so you have 7b. So that is correct right off the bat. If you add 7 to b, I guess that was the first one, that's different from that. If you multiply 7 b's together, what's that equal to? That's not 7b, that's b to the 7th power, right? So that's different from 7b. 7b plus 4 divided by 4. Oh, that's certainly not 7b. You can't just get rid of those. That's not right. 14b divided by b. What does that give you? If you divide out the b's, you get 14. Oops, I have 2b there. 14b divided by 2b, so the b's cancel, and the 14 cancels with the 2, and you just end up with 7. So that's wrong. And finally, you have 3.5b times 3.5b. If you multiply that out, you're going to get 3.5 squared times b squared. So if those were added together, then you would have 7b. That's 3.5 and 3.5. If you added those together, sure enough, you'd have 7b. But here you're multiplying them. So multiplying them, that's not the case. Okay, that was a good problem. How about number 18? Body mass. This is body mass index, BMI. Okay, all these technical things here. Okay, BMI is used by physicians. BMI is used by physicians to assess a person's body fat. BMI varies directly as a person's weight in pounds. So as soon as I hear that, I'm going to go varies directly with the weight. So W is going to stand for the weight, and to vary directly means the weight is up there in the numerator, and if it varies, that means that there's a proportionality constant. So there it is right there. And it inversely as the square of the height. So inversely means it's down in the denominator and the square of the height. So there's the square of the height. So W is the weight in pounds, and H is the height in inches. Okay, a person who weighs 179 pounds, so now we know that a weight is 179 and is 72 inches tall, has a BMI of 24. Okay, so once I know that, I can now find out what this K is. So let's find out what K is. So here's what I know. I know that 24, the BMI, is equal to K times 179 divided by, the height is 72, so it's going to be 72 squared. See that? So now I can find K. So what's K going to be? K is going to be 72 squared times 24 divided by 179. Okay? And those are way too big of numbers for me to do without a calculator, so let's go ahead. 72 squared times 24 divided by 179, I get 695.06. So that rounds to 695. Okay? And now that I have that, I can solve the problem. Because what's the problem say? It says find the BMI of a person who weighs 155 pounds. So now I can just calculate it. Here we go. BMI. Here's our K, 695. And we're told that the weight is 155. And we're told that the height is 63 inches. And so we square that again. And when we do that, what do I get? Again, I have to use my calculator. So it's going to be 695, going to be 155 times 63 divide 63 divide. 27.14 is what I get. And let's see if that's an answer. Yep, it comes close to 27. Okay, very good. One problem left. Get out of all these numbers here. Number 20. 20 says, if we were to multiply x plus 2 times x minus 5, what would we get? Oh, wow, these are easier now. Here's the way I like to do it. I just take x plus 2, and here's x minus 5, and I just multiply them together. So just like when you multiply numbers, it's going to be negative 5 times 2 is going to be negative 10. Negative 5 times x is a negative 5x. X times 2 is 2x. And x times x is x squared. So I can just put them all down like that and combine them, and I'm going to get what? X squared. Here I have minus 3x. And here I'm going to get minus 10. So there's my answer. If you use the FOIL method, it amounts to the same thing. First is x times x is x squared. Outer is going to be a negative 5x. Inner is going to be a positive 2x. And finally, the last is going to be minus 10. So it's going to be x squared minus 3x minus 10. Same thing I got there. Okay, very good. So that is up to number 20. So in the next video, we will do 21 through 30.